Assalamualaikum and good morning to Madam Izzati. Today we are going to do question calculus 1 analysis function. This is our group members and ID numbers. So let's go to the questions, the analysis function. So we have a given function here which is fx equal to 3x squared minus x cubed. To do analysis function, we have few steps to do, which is the first one is find the x-intercepts of function. B, find the intervals where f is increasing or decreasing, hence determine the relative extremum of f if any. C, find the intervals where f is concave up or concave down, hence determine the inflection point of f, the function if any. The last one is sketch the graph of function using the above information. So let's go to the next slide. Okay, the first step is we are going to find the x-intercepts of the function 3x cubic 3x squared minus x cubic. Solution is we need to make the function into quadratic, and with making the fx equal to 0 and substitute the fx with the function 3x squared minus x cubic. So after we doing this, we will get the x values, which is 0 and 3, and then we're going to substitute the x value into the function and get the coordinate. After that we're going to substitute the x values into the function and get the coordinate of each x value. So the x-intercept will get the function of we will get the coordinate of 0, 0 and 3, 0. So the next step is we will going to find the intervals where f is increasing or decreasing, hence determine the relative extremum of function if any. So we need to differentiate the function and get the 6x minus 3x squared. After that, the second step is we're going to make the function equal to 0. So 0 equal to 6x minus 3x squared, and then we will going to find the x values. So after that we will do the critical line to see the range of the interval. So the next one, the step 4 is we're going to find we will going to do the first derivative table where there is 3 columns. The first one is interval, second one is test value, and the last one is sign of the differentiated function of 6x minus 3x2. Okay, the first interval is we're going to take the left side of 0 from 0 to until the left side of 0, which is infinite numbers of number or of the left on the left of 0. So we can so for the test value we can pick any numbers from 0 to negative the negative infinite, which is infinite numbers of negative. Okay, and then we will go into substitute the test value into the function, the differentiated function, and we will get the value. And see the whether it has a positive or negative sign. So for the interval, the next interval is 0 to 2. So we will going to take number from the range from 0 to 2. It's either 0, 1 and 2. And then we're going to do the same thing, substitute it into the function, the differentiated function, and we will get the positive sign. So the last one is from 2 until the right side of number 2, which is infinite numbers of number. It could be anything on the right side of number 2. Okay, so we're going to test it with 3, and we're going to substitute it into the differentiated functions and get the negative 9, which is it has a negative sign. So for the step 5 is choose the correct sign. So as you can see from the step 4, we see that the interval and the sign of the differentiated functions, after the test values substitute into it, we will get the sign of positive or negative, right? So by that we can determine whether it is in increasing interval or decreasing interval. So from 0 to 2, the coordinate, we will be increasing interval because it has a positive sign, while from 0 to negative infinites of numbers to okay. So while for 0 to negative infinite will be decreasing interval, so the number 2 to infinite. Alright, the next one is we're going to determine the extremum point. So substitute the x value into the functions, which is not the first function, which is 3x squared minus x cubic. Okay, substitute the x equal to 0 and get we will get 0 as the function's value. So we're going to have minimum point 0, 0. From the critical line, we have the value 0 and 2. Then substitute the numbers into the function. The first function, which is fx equal to 3 squared minus x cubic. So for that, when x is equal to 0, we will get the function equal to 0, and then we can determine the minimum point of it, which is 0, 0. So when x is equal to 2, just substitute it into the function, and we will get the function value the function value is 4. So it will determine the maximum point of the function, which is 2, 4. And then for step 6 is determine the extremum point. Based on the coordinates that we just found, we can determine the extremum points, and then we just need to find the second derivative of the function, which is after we differentiate it, we will get 6 equal to 6x. The next step is the step 8. Let the second derivative function equal to 0, and then we will get the x value of 1. After that, for step 9, we will do the inflection line, where it shows the range of the value between the x value 1. Okay. Step 10, we will do the second derivative table, just like the first derivative table. We will do the same thing. The interval from 1 to the left side of it, which is it could be a negative infinite of number, and we will test it with number of the number negative 1. After that, we will substitute the number into the function, and we will get 12, which is it has the positive value, the positive sign. And then after that, we will substitute the test value to the function, and we will get number 12. So we're going to substitute the negative 1 into the function, and we will get 12, which it has a positive sign. And the next interval is from 1 to the right side of the number. It could be a negative infinite of number, So the next one is we're going to do for the next interval, which is 1 until to the right side of the number 1, which it could be. So we will test it with 2 and substitute the number 2 into the function, and we will get negative 16, which it has a negative sign. So the next step is find the intervals where f is concave up or concave down, hence determine the inflection point of f if any. Alright, so step 11 is choose the correct sign. For any numbers that have 11, we're going to choose the correct sign. So if the sign is positive, it will be concave up, which which is the number 1 to negative infinite of number, it will be concave up, while for negative sign it will be concave down, which is the 1 to negative infinite of number. After that, step 12, we will determine the correct inflection point where x is equal to 1. Then we substitute it into the function, the first function, and we will get the value of 2. Then the inflection point is 1, 2, and then we're just going to sketch the graph of function using the above information. That's all.